All right. This is a two-sample hypothesis test. The two-sample test is used when we want to compare two means to each other. The setup for this particular example is that Bob notices that the gray squirrels on the Findlay campus tend to weigh more, he thinks, than the black squirrels. So he wants to test this hypothesis. He wants to be very certain of his results, so he's using a level of significance of 0.01. And to do the test, he takes a sample of 30 gray squirrels, and then he's got the mean at 1.6 and standard deviation at 0.4 for that. And he also takes a sample of 12 black squirrels with a mean of 1.4 and a standard deviation of 0.2. So, as always, we want to kind of put this into the mathematical notation. I want my null hypothesis and alternative hypothesis. Here, for these two sample tests, we're always comparing two means. So we want to reflect that in the hypotheses. Here, the null and the alternative is always the difference between those two means. So we're using mu sub 1 to represent the mean weight of the gray squirrels, mu sub 2 to represent the mean weight of the black squirrels. The null hypothesis here is that they weigh the same. Then the alternative hypothesis, Bob thinks that the gray squirrels are heavier, so he thinks that mu1 should be more, and that difference then should be something positive. So that's my null and alternative hypothesis. Next, I want to dig all of my information out of the problem. My point estimate is this x1 bar minus x2 bar that reflects these two. That's my estimate of that mu1 minus mu2. X1 bar represents the mean of the gray squirrel sample. So we get 1.6 for that. S sub 1 is the standard deviation of that sample. N sub 1 is the sample size. And again, for the black squirrel sample. So those are the statistics for those two samples. Next, we want to determine our t-value for the sample. And again, my t-value is determined essentially by that z-score formula. I'm taking x minus mu over standard deviation. I've got different things representing those for this. X1 bar minus x2 bar. This is t. X1 bar minus x2 bar is going to be 0.2. Mu1 minus mu2, again, that's my null hypothesis, so we're assuming that is 0. And then on the bottom, I've got the standard deviation of this distribution. So .4 squared over 30 plus 0.2 squared over 12. And then the square root of all of that. This is stuff to punch into the calculator. I get 0.2 on the top and 0.0966 on the bottom. And this gives me a t-value of about 2.07. Then this starts to look like a normal hypothesis test. I want to compare that t-value to the alpha I was given. So I want to compare that to this 0.01. Again, I have to switch my t-value into a probability, or I need to switch that alpha into a t-value to be able to compare those two. To make that switch, I need to use the degrees of freedom, which for this particular test is this horrible looking formula. I have all of these pieces. It's just a matter of crunching through all of that to figure out that degrees of freedom. In this particular case, so I'm plugging in S sub 1, S sub 2, N sub 1, N sub 2 to all of that. For this example, I end up with about 31.6. And for this case, for these degrees of freedom, we always round down. So we truncate that to 31. So I've got my t-value, I've got the degrees of freedom, and I've got my alpha. Now it's just a matter of comparing those two. If I take this alpha and switch it to a t-value, using that 31 degrees of freedom, I look that up on the chart. I get a t-value of about 2.46. And if I compare that to the t-value for my sample, my t-value for alpha is farther away from the mean than the t-value for my sample, so I'm going to fail to reject the null hypothesis. So the picture is my t-value for alpha is 2.46. That's my critical region. My t-value for the sample is the 2.07. And that's not inside that critical region. So I fail to reject that null. I can also take this alpha, or take this t-value and convert that into a p-value and check to see if that's less than alpha or not. On the calculator, this is called a two-sample t-test. It will ask you for the statistics for the two different samples. The calculator will figure out the degrees of freedom for you, which is nice. And the calculator will spit out the p-value, which then you can immediately compare to alpha. Alright, so I think that's it for that one.